On here, and let's go now to our limiter section. So under the limiters, we have our engine coolant temp speed limit, we have our engine average load speed limit, we have our maximum speed limit, and then we have engine oil temp speed limit. And we also have our ignition and fuel margins and ranges. So taking a look at this, I am going to set my engine speed limit here to 9,000 across the whole coolant temp table. What I'll find here on the cold coolant temps, I might only want to allow the engine to rev to 6,000. And then if it gets really hot, above, let's say, 140 Celsius, extremely hot, I'll only allow the engine to rev to 3,000 and maybe 120, even going down to something like 4,000 because the engine's starting to get hot. But between 40 and 100 Celsius, it's my normal operating range. That's going to be where I allow the engine to rev pretty much all the way out to 9,000. This engine, I'll probably only really rev it out to 8,500, but I want my rev limiter a little bit higher in RPM above where I plan to rev my engine, about 400 or 500 RPM higher than my actual desired peak engine speed. So 8,500 is where I'm going to consider revving the engine to. 9,000 is going to be where I put the limiter. Now the engine load speed limit, we're going to put to 10,000. The driver speed limit maximum, we're going to set this to 10,000. And then engine oil temp speed limit, 10,000. We're raising the other thresholds because the Motec's always going to use the lowest of all of the limiter tables. So whether that's going to be launch limiter, whether it's going to be traction control, whatever is currently calling out a lower limiter, that's what it's going to use. So I want to go and raise these others because I don't find them very valuable. If I had engine oil temp actually installed in this for a road race car, this might be something to be concerned with and set this up. I don't have oil temp. I'm going to bypass that. My speed maximum here, I'm not going to use. I am going to essentially call out my main rev limiter right from my coolant temp base table. So this is going to be my overall rev limiter based on coolant temperature. It gives me a fail-safe strategy. Now, parameter list here, this is our engine speed limit. This is going to call out whether we're going to have a spark cut limiter or a fuel cut type limiter. So looking at this, ignition range is 200 RPM, fuel margin 500, and then fuel range 100 RPM. This is going to say 200 RPM before 9,000, it's going to start to cut the spark progressively. Once we hit 9,000, it'll have a full spark cut, so 100% cut. Then the fuel range here set to 100 RPM. This will start to wait then that many RPM higher in order for a fuel cut to be implemented. If we have 100% ignition cut, it's not going to go any higher than that limiter. So the default settings in here, and most all the Motec maps from what I've always seen, they always set it to a spark cut limiter. The limiter strategy is super smooth on the Motec. Really no concern running an ignition cut for most engines. I'm going to leave it on the default settings for Motec. This should work perfectly fine, having an ignition cut type of limiter. Engine speed limits. Taking a look here, we're going to find this is going to give us an overall review of what is in play in terms of our limiter and other limiter strategies. We can see what's called out here from our various different tables. Again, we see a lot of the same information over here in our limiter window. It's kind of a redundant window in my layout here. Okay, let's go here to our safeties. So we can program our safeties. This may or may not be something you want to do. There's a warning and a safety. So a warning is going to just warn you down here when there's a problem. It'll give you a little warning window, or you can set up a warning window in any of your template windows to tell you that there's a problem with oil pressure, oil temperature, something along that nature. Then you can take an actual action and cut the ignition, cut the spark, put a limiter in place. So if it trips the warning for a certain period of time, it can go into the limiter. Now, in a naturally aspirated engine like this, I'm not really worried about implementing a limiter other than coolant temperature. That's my main concern, and I've accomplished that here in my limiter strategy in my coolant temp based table. So under my safety here, in my first safety window, I could put a lean protection with the lambda if I desire. I'm not going to do that. We can take a look. That's disable. There's an ECT safety. I'm going to turn this off. I don't care about having this enabled simply because I have that table already set up. If it overheats, it'll start to limit me. Oil pressure, I don't have an oil pressure sensor, so I'm going to keep that disabled. Oil temperature, I don't have an oil temp, we're going to keep that disabled. Move here to our safety 2. There's fuel pressure safety. This may be a concern. I'm not going to turn it on yet. I want to see what the system does as I start to do full throttle pulls and see if the fuel pressure is staying relatively consistent. Inlet air temp safety, I'm not worried about. Fuel injector duty safety. This is going to tell me if my injectors get above a certain amount. We could go here for the warning and then just enable this. If we turn this on right here, we don't necessarily need to have a limit. So we can see here engine speed limit. This would be 0 RPM. Let's just put this really high, something like 10,000 RPM, so it's not going to kick in. So if we exceed 90%, it's going to give us a warning. This is just going to delay factors here. So it's going to wait 0 seconds to actually allow us to see the warning. So it's going to kick in right away. That's just going to be easier to keep track of what's going on. So it'll tell me if there's a problem with the duty cycle. If we're getting too high injector duty cycle, that's definitely a concern. We're going to run out of fuel flow. So I'll keep this warning on, but we're going to raise that speed limiter up so it's not going to go and kick into a rev limiter. I don't need that just yet. So we'll keep that configured. There's an engine speed safety here. Looking at this, this is going to say if we get above this RPM or below this RPM, it'll give us a warning. I'm going to turn this off because we have our limiter already applied. And we're going to raise this engine speed limit up here to 10,000 RPM just to make sure that's out of the way. Okay, there's an all calibrate window. We do need to set up a few things, specifically outputs. We have VTEC we need to set up. We also have variable cam control we need to set up, and also our drive-by-wire configuration, specifically our Excel pedal position sensors, and then the outputs to control the servo motor and the throttle position sensors from the actual drive-by-wire throttle body. So we need to use some of our all calibrate window here to do some of this task. Let's go here to our auxiliary output. We're going to use our output 1, and the output 1, we're going to assign it for a main relay control. So in a Honda, we have to turn on the main relay to power up the entire harness so that things actually function and work, like our sensors are going to read. They all have a 12 volt or a 5 volt reference, specifically 12 volt reference. There's going to be a lot of 12 volt references, and if the 12 volt reference isn't turned on, then other things won't work. So cam and crank sensors, for example, won't actually register and read unless we have our main relay armed and turned on. As soon as we turn the ignition key on, we want the main relay to turn on to spread the 12 volt power reference out to the engine harness. So we need to go and assign this using our aux1. It's going to be really easy to set this up. Essentially, key on, engine off, we want it to turn on, or even when the engine's actually running, it always should be on. So if we go in here and take a look at our input and outputs in my list, under the outputs, main relay should be set to LS5. That's what we want to designate for an auxiliary control. So we're using a generic output to do this. So LS5, let's go down here. So low side 5, and it should be low side injector. Looking at this, I believe it's going to be the injector output. We'll have to verify that. We can find as soon as we actually power up the vehicle and load this file if it's accurate or not. So it should be low side 5. State, we obviously aren't going to see anything in the offline, so we're going to see nothing here. We're not going to do anything with the testing. The polarity, normal. Frequency should be 0 hertz. And this auxiliary duty cycle output should just be simply set 1D value 100%. And we're low side outputting, so meaning we want to send a ground signal out to ground the main relay to turn it on in the vehicle here. We're sending a low side output 0 to 100 in the output control. 0 off, 100 on. Simple as that. We don't need to do anything else with the activation threshold. So minimum should be 0, maximum should be something like 400. Hysteresis 0, race time 0, speed hysteresis 0, minimum 0, maximum 400. So essentially now we're saying we want it to turn on and stay on. We're not going to do anything with the switch. Keep that to 9.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.